All right, so what do we got here? 20 parts per million of a dangerous contaminant in and our cleaning process removes 5% of the remaining contaminant each day. So every day we take 5% of what's left, right? And I imagine it's in say liquid, so it's 20 parts per million in some type of water, I guess I'll think about it as that. Or it could be solid, it could be like it could be in the soil too, something really pollutant, really toxic in the soil maybe, I don't know. Okay, so days and then what's remaining, but those are the two things we're thinking about here, because each day we remove more contaminant and we remove 5% more from the previous day. Make sense? Alright, so what I'm going to do is just put up a little table here, and each day we're going to remove more, and so we'll have amount remaining. And if I do a table, it should explain the whole thing and help me answer any questions I want with this. But day 0 is now. That's when we begin the cleaning process. And we have 20 parts per million. So I'll just put down 20, right? And the amount remaining is in parts per million. So I don't have to keep writing the units over and over and over. So I mean, think about something like mercury in drinking water. You know, like 20 parts per million, even though that's it's only a little amount. If you've got 20 parts per million of mercury in your drinking water, that's pretty bad for you, right? Because it doesn't take much mercury to hurt you. Similarly, lead, and you know, all sorts of other things in the world. I'm sure you can all think of more things than that. But so after the first day, we have 95. We have 5% is removed. So, you know, 5% of the 20 parts per million is removed. Does that make sense? And so we can get 5% to 20. That would just be 0.05 times 20, right? Which is 1, and then we can go 20 subtract 1 to get 19, right? So that's one way of doing it. That's taking the 5% out. And then we can keep going. There's actually a cooler way of doing it where so here we had to multiply and then subtract, right? But how can you remove 5% by just multiplying? Like, how do you do it by just doing one multiplication rather than multiply and then subtract? So, what if we just got 95% of 20 is all I was trying to say, right? That would work, wouldn't it? And that's how we remove the 5% all in one go, just by multiplying, right? Just because it's handy, and it might, if we had to find a formula, it would help to do that, right? Which we will. So 95% 20, you turn it into a decimal, multiply, and it just looks like this. It just goes, 0.95 times 20, and if you plug that in your calculator, you just get 19, right? So after one day, it's just, or even better, 20 times 0.95, right? So after 2 days, there's the 19, and I'll do it the long way over here. So like I'll go. Well, you know what? I'll get some scratch paper out here, and I'll go. Okay, I gotta get 5% of 19, and then take it away, right? So is I'm getting removing 5% each day, right? So 5% times 19, 0.05 times 19 gives me 0.95, and then I go 19 minus 0.95, and I can just do it on a calculator, obviously. 19 minus 0.95, and of course I get 18.05, right? Right. But what's the cool way of doing it? What's a faster way without having to is there a faster way? Correct? Right. Well, yeah. You could go 20 times, yeah, like you were saying, 1 minus 0.05. That would work, right? Because that's actually 20 times to the power of 2, right? Or that's just 20 times 0.95, isn't it? Yeah, 95%. So we're getting 95% to 20 to get 19, and then we're getting, 95% of the 19 to get the 18.05, or 20 times 0.95 to the power of 2. Yep. Okay, so then day 3, how much is remaining? And can we come up with so day 1, by the way, we could have done this: 20 times 0.95 to the power of 1, right? That would be 1 day. And after day 2, it's 20 times 0.95 to the power of 2. So after day 3, what's remaining? Yeah, good job. So we can go 20 times 0.95 to the power of 3, right? Which, as you say, it's fine to do it this way. It's 1 minus 5% done 3 times over, so to speak. Same thing. And yeah, so just round that. So 20 times 0.95 to the power of 3. And by the way, in the calculator, I'm just writing that 20 star 0.95 to the power of 3 in the calculator. Or I'll just put, for anyone that's watching from home, let's put it all in. You could also do this: 1 minus 0.05 to the power of 3. So this way or this way will work, whichever way you prefer. Same thing. And in any case, that's 17.1475, so approximately 17.15, right? So how much is remain? So after day 3, we have this amount remaining. But think about how much was removed, right? So amount removed, because we started with 20 parts per million, right? And we could do a little. So right, so it's amount, right. So if we think about the amount removed after the first day, we've 19 remaining, but we started with 20, and 20 minus 19 is 1, so that's 1 part per million removed. Does that make sense? And so on, and so then on day 2, we've got this remaining, but hold on a second, that's 20 minus 18.05, so that would be, after day 2, we have, 1.95 was the amount removed, right? Removed, all right, and so on. And so day 3, we got 17.15 remaining, but that means that there was 20 minus that removed, so 20 minus 17.15, which is 2.85 was removed, right? Okay. All right, so, and that should answer, because I think the first question was how much contaminant is removed during the first 2 days. During the first 2 days, then that answer would be 1.95. Yeah, perfect. All right. So that would be that. Now, then the next thing is they're asking us things like how much contaminant is removed on days 10 and 11. On days 10 and 11, how much is removed on days 10 and 11? Okay, so, well, let's figure this out for day 10 then and 11. How about that? So, if our day was 10, how much would be remaining? Oh, but that is on day 10. Okay, see, that's the thing about these questions. It's like on day 10 and 11. Don't we want to know? Don't we want to know what was remaining at the end of day 9, and then at the end of day 11? You know what I mean? Yeah. So just for fun, I'm just going to go 9, 10, 11, because when it says on day, if it's removed on day 10, then I kind of want to know what was left in there at the end of day 9. You know what I mean? So I'm just going to calculate for day 9, 10, and 11, and then I'm going to think about that question again. Alright, so let's figure it out. So how much would be remaining at the end of day 9, the end of day 10, the end of day 11? Right? So just 20 times 0.95 to the power of 9, and this is 20 times 0.95 to the power of 10, and so on, right? Right. And calculator speak, it looks like this. Okay. All right. So, and we'll just round it all to. So 20 times 0.95 to the power of 9. 12.6, I guess. Good enough. So approximately 12.6. And then I can just highlight that, put in a 10. So at the end of day 10, I got 11.97. And the end of day 11, I've got 11.38. Right? So, the way I'm reading this is at the end of day 9, we have this, and then throughout in day 10, we removed from this amount to this amount, and then throughout day 11, we removed from this amount to this amount. So the way I'm interpreting this is it says how much contaminant is removed on days 9, on days 10 and 11. Well, do they want two separate answers, or do you want us to add it up together? That's the question. Well, I'll do it both ways. It's kind of a funny question, but if I subtract just what happened when we went from here to here, from like here to here, and then what happened when we went from here to here. That's all we need to figure out, really. So just go, right? So we removed 0.63 on day 10, basically. And then 11.97 minus 11.38. We removed 0.59 on day 11. All right? And I guess we could add them together as well. So 0.63 plus 0.59. So combined, it's we removed 1.22 altogether. So basically removed 0.63 parts per million ppm on day 10, and we removed 0.59 parts per million on day 11. So that means we removed 1.22 parts per million on both days, altogether, on both days, basically. Yeah. All right, cool. Good one.